Hello guys and welcome back to 5 minutes of channel. In this video I want to show you what is a EKMF Web edition and what can I do with it. EKMF is the acronym of Enterprise Key Management Foundation, and it is a flexible and high security key management system for the enterprise. It provides centralized key management on IBM Z machines and distributed platform for an easy, efficient, and secure key and certificate management operations. EKMF serves as the foundation on which remote cryptographic solutions and analytics for the cryptographic infrastructure can be provided. EKMF is available in two forms, as EKMF Workstation and EKMF Web. EKMF Workstation is an IBM solution offering implemented as a self-contained hardware appliance, including a dedicated workstation and Linux operating system. EKMF Workstation supports many key types with authentication done using smart card with PIN. The security controls enable EKMF Workstation to be PCI compliant, then to have higher security rating and administer more complex key types. EKMF Web Edition was officially released as a software product in April 2020. And it uses the same infrastructure in terms of KMF agent used by a KMF workstation to communicate with ICSF through APIs. It runs in a ZOS LFR image and it is accessible through a web browser. It provides all the basic functionalities to manage keys. Currently, it supports generation and management of keys used in dataset encryption, as well as setting up keys for cloud deployments, such as IBM Cloud, Amazon Cloud, and Microsoft Azure. EKMF use WebSphere Liberty application server running on ZOS in order to provide a GUI to the end users. AJB rules define the authorization to EKMF Web functionalities. Keys are generated by EKMF Web and stored in the EKMF key repository. They are secured by the master key residing in the HSM, which means the EKMF Web never gets to see the key in the clear. EKMF key repository backend is provided by DB2, running on ZOS. Normally, resiliency, backup, and recovery process and procedures for ZOS DB2 should be used to protect the repository. Target key stores are defined to the EKMF Web for remote distribution. Based on policy defined in key templates, keys are distributed to the key stores whenever they may be needed. If a key is lost or deleted from a particular target key store, EKMF Web can restore the key by redistributing it. If a key needs to be archived or deleted, EKMF Web can remove the key from the connected key stores. What are the requirements for EKMF Web? They are represented in this slide, and you can see the ZOS 2.3 or later, DB2 repository, ICSF has to be initialized, and WebSphere Liberty for the GUI, and the crypto adapter initialized with master key set. EKMF Web interface is performed via web browser. User must log in using credential authenticated by RACF or LDAP. The authorizations are managed by GB rules to determine the right user profile. Once logged in, on the main menu, you can find the navigation tabs on the left side that allow you to navigate between the functions. With the EKMF Web, all the keys are generated by EKMF Web Server and stored in EKMF Web Repository, DB2. Based on the policy and on GUI request, keys are then installed into the local key stores. For this to work, the EKMF Web must connect to ZOS CKDS key stores. On each LFR, EKMF has an agent that listens for requests and issues that underlying CSF API calls to load the keys into the CKDS. These require an EKMF agent to be installed on each system that has a unique CKDS. If you are sharing a CKDS in a sysplex, for example, you need one agent per sysplex. All keys that are generated by EKMF Web must be generated from a template. The template defines the key label name, key stores where keys should be installed, and key characteristics. Typically, the key administrator role has access to create the key template, whereas the key custodian have access to use the template, and the auditor role would have read-only access to the template. There are a number of key fields to consider when creating a key template, such as key size, key type, key state, key template state. If active, it can be used, and if archived, it cannot be used, for example. Export, this setting a low key to be exported. You have to only select this if you have a valid reason to export the key template. Key activation, this is a setting period for how long the key will be active and from when it will be expired. When creating the key label, it is important to have in mind a good strategy on naming convention. The key label typically describes the area where the key will be used, the application key that will be used, and the sequence number. It is considered a best practice to have a sequence number as a tag. EKMF Web will provide the next sequence number during a request as shown in this picture. The lifecycle of keys is one of the most important aspects of the key management. NIST has defined the process for the key lifecycle, which defines the flow for key generation. EKMF Web provides all these functionalities to manage the key lifecycle, such as activate, to install the key in the key store for the first time. Restore will ensure keys is in all defined key store. Deactivate to remove the key from all key stores. Compromised can mark the key as compromised, and destroy to remove the key from EKMF Web centralized key repository. EKMF Web provides a dashboard view of dataset on the system. To achieve this, EKMF Web uses two batch jobs. The first job reads the master catalog to create a detailed extracted of dataset of the system, and the second job takes this extract and loads into DB2. These jobs should be run on each LPAR, the OS image, at an interval that you have to set. Once a day should be sufficient for more reporting requirements. Then you can review results by going to the dashboard found into the dataset tab. Datasets are viewed at sysplex level. You can refine the search by specifying creation date, dataset state, or dataset name on the key label, and the encryption status. Additional details for individual dataset can be viewed by clicking on the dataset name, and you can see if the dataset is identified as encryptable or not encryptable. In addition, you have a pop-up reason provided at the bottom of the screen that informs you the action needed to enable encryption on the specific dataset. And thank you for your attention. And if you want to know more on Z-Security, subscribe on my channel and follow me in the next video. Bye bye from Luigi.